cycle followed by an engine made of 1 mole of perfect gas in a cylinder with piston is shown in the figure. The path AB has constant volume, path BC is adiabatic, path CD has volume constant, and path D to A is adiabatic. The relationship between all the volumes of the states is also given. In the part A of the question, it is asked which part of the cycle heat is supplied to the engine from outside. In the whole cycle, the path BC and path AD are adiabatic. So there is no heat transfer in both the paths BC and DA. The heat is transferring from the surroundings to the engine and to the engine from the surrounding only in path AB and CD. Let's look at the path AB. In path AB, the volume is kept constant and the pressure is increasing. The volume is constant, it means it is an isochoric process. So pressure is proportional to temperature. As the pressure of the gas is increased, we can say the temperature of the gas is also going to increase, and this temperature increase is going to lead to an increase in internal energy. So delta U from A to B will be greater than 0. From the first law of thermodynamics, delta Q is equal to delta U plus delta W. In the path AB, the change in volume is 0, so the work done in the process AB will be 0. So this term is going to be 0, and the term delta V and the term delta U is greater than 0. So this implies delta Q going from A to B is greater than 0. Delta Q going from A to B greater than 0 implies that heat is supplied to the engine from the surroundings. So for the part A, the answer is path AB of the cycle. Heat is given to the system. Let's go to the part B of the question. In which part of the cycle heat is being given to the surroundings by the engine? In the path CD, the volume is constant and pressure is decreased. So even in the path C to D, we can say pressure is proportional to temperature, and as pressure is decreased, temperature is decreased, and delta U of this path C to D is going to be negative. And as stated before, delta Q will be equal to delta U, and this is going to be less than 0. So delta Q going from C to D will be less than 0. This means that heat is expelled out of the system. So for the path CD, heat is given out to the surroundings. Let's look at part C of the question. Let's redraw the graph of the cycle. These two are the isochoric processes and these are the adiabatic. This is A, this is B, this is C, and this is D. So work done in the whole cycle, delta W of the whole cycle is equal to work done in path AB plus work done in path BC plus work done in path CD plus work done in path DA. As we have already seen, work done in path AB and CD are going to be 0. So these terms are going to be 0, and we are left out with delta W of cycle is equal to work done in going from B to C plus work done in going from D to A. For an adiabatic process, the equation of the state is given by PV power gamma is constant and the work done is equal to integral P dV. From this relation PV power gamma is constant, we get the value of P as V power minus gamma into C, and substituting this value into the work done, we get W is equal to integral CV power minus gamma dV. So for the work done in the path B to C, we can write integral volume at B to volume at C, CV power minus gamma dV. So this is going to be C V power 1 minus gamma by 1 minus gamma with the limits VB and VC. This is going to be equal to C by 1 minus gamma into Vc power 1 minus gamma minus Vb power 1 minus gamma. As the points B and C lie on the adiabat, we can write Pb Vb power gamma is equal to Pc Vc power gamma is equal to C, and substituting these values in the expression of the work done, we get W is equal to 1 by 1 minus gamma into Pc Vc power gamma Vc power 1 minus gamma minus Pb Vb power gamma Vc power 1 minus gamma. Therefore, W is equal to Pb Vb minus Pc Vc by gamma minus 1. So this is the work done from going from B to C is equal to Pb Vb minus Pc Vc by gamma minus 1, and similarly we get delta W from D to A as PD Vd minus PA Va by gamma minus 1. So the work done in the whole cycle, delta W of the cycle, will be equal to Pb Vb minus Pc Vc by gamma minus 1 plus PD Vd minus PA Va by gamma minus 1. We have the relations Pb Vb power gamma is equal to Pc Vc power gamma and PA Va power gamma is equal to PD Vd power gamma, and also Va is equal to Vb, which is equal to half of Vc, which is equal to half of Bd. So let's eliminate all other variables except Pa, Pb and Va. First let's substitute Vb as Va as they both are equal. So delta W of the cycle will be equal to Pb Va minus Pc is minus Pc into Vc is 2 times of Va, so 2 Va plus Pd into Vd is 2 Va minus Pa Va whole by gamma minus 1. So this is going to become VA by gamma minus 1 into PB minus 2PC plus 2PD minus PA. From the relations, we can write PC is equal to PB into VB by VC power gamma, and VB by VC is 1 by 2. So PC is equal to PB by 2 power gamma. Similarly, we get PD is equal to PA into VA by VD power gamma, which is equal to PA into 1 by 2 power gamma. Let's substitute the values of PC and PD into this. So we get the work done is equal to VA by gamma minus 1 into PB minus PA plus 2 times of PD minus PC, which is going to be equal to VA by gamma minus 1 into PB minus PA plus 2 times of PD is PA power PA, PD is PA by 2 power gamma. So this is PA by 2 power gamma minus PC is PB by 2 power gamma. So from this we write VA by gamma minus 1 into PB minus PA plus 2 power 1 minus gamma into PA minus PB. So finally we get the work done in the whole cycle as VA by gamma minus 1 into PB minus PA into 1 minus 2 power 1 minus gamma. So this is the expression for the work done in the whole cycle. Let's go to part D of the question. Of the cycle is defined as work output by the cycle by heat given into the cycle. So the heat given into the cycle is only in the path AB. So the heat given will be Q of AB. We have already seen the work done in the whole cycle as the expression which we have derived before, and QAB, delta QAB will be equal to delta U of AB plus 0, which is the work done in going from A to B. So delta U of AB is equal to NCV delta T, and CV is given to be 3 by 2 R and N is 1, which is given in the question. So this will be 3 by 2 R delta T. Therefore delta Q from A to B is equal to 3 by 2 R TB minus TA. So the efficiency of the cycle will be equal to VA by gamma minus 1 into PB minus PA into 1 minus 2 power 1 minus gamma into 1 by 3 by 2 R TB minus TA. PAVA is equal to RTA and PV VB is equal to RTB. Therefore, and also in this process, VA is equal to VB. So subtracting these two equations, we get PA minus PB into VA is equal to R into TA minus TB. Let's substitute the value of R into TA minus TB back to the equation of efficiency of the cycle. So efficiency of the cycle comes out to be VA by gamma minus 1 into PB minus PA into 1 minus 2 power 1 minus gamma into 1 by 3 by 2 into PB minus PA. Here we have substituted the value of R TB minus TA, which is going to be PB minus PA into VA. So finally this is going to become 2 by 3 into 1 by gamma minus 1 into 1 minus 2 power 1 minus gamma. In the question, gamma is given as 5 by 3. So let's substitute the value of gamma as 5 by 3. So this is going to become 1 by 2 by 3 into 1 minus 2 power 1 minus 5 by 3. So this is equal to 1 minus 2 power minus 2 by 3. So this is the final value of efficiency of the cycle.